The pH of a 0.0516 molar solution of nitrous acid is 2.34. The question is, what is the Ka? All right. So let's start and do our ice table. First, we're going to do the initial concentration. All right. And this is the HNO. This is the HNO2 column, and then we have the hydronium ion and the nitrous anion column. So it gives 0.0516 molar solution of nitrous acid. That is the total solution at time t equals 0 of nitrous acid. And so I'm going to put, and if you guys disagree or do not see this, please let me know. But that's 0.0516. That is the initial concentration of nitrous acid. Now it's not all nitrous acid once you put it into solution. So it's a little bit, you know, of a, you have to just think in terms of total nitrous acid, right? At time t equals 0 is what they give us. Now, can someone tell me at time t equals 0 what the concentration of hydronium ion would be? And there's one a caveat I want you to have to use in these equations, unless you're told otherwise. Let us disregard the autoionization of water, okay? Disregard the autoionization of water. The reason being is we are adding strong acids to these, or strongish acids to these solutions, much stronger than the autoionization of water in terms of its acidity. So we can neglect it. It's there, but it's way far off into the decimal places of our final numbers, which will not influence the accuracy. Does everyone see that? Understand kind of what I'm talking about there? We're talking about adding acids. Yeah, okay. So let's disregard that. So if that's the case, can someone tell me what the concentration at times t equals 0 of the hydronium ion is? Anybody?
Should be 0.
That's exactly right. Does everyone agree with that? All right, good deal. 0. How about the anion? 0 too, isn't it? It hasn't ionized at times t equals 0. It's just sitting there. Now, what is the change? All right, here it gets a little more interesting. We're given the pH. Now I'm going to double line this one. The pH is 2.34. All right. Now we know that hydronium ion is pH, right? It's just a reflection of pH. It's another way to numerically express it using the pH scale, using the log scale. So I'm going to offer that we are changing the hydronium ion concentration in this solution to the extent of a plus, and again I'm doing 10 to the minus 2.34. Does everyone agree with what I just did? And thinking back of how we just walked through that math, okay? It's the concentration. It's just, I'm just reflecting it in terms of the base 10 concentration. You can do that. We can easily convert it. All right. I'm going to say that the nitrous anion is exactly the same thing. 10 to the minus 2.34. All right. Now, we got one blank to fill in. We're not worried about water. Let's just don't worry about that. It's not an issue. It's constant. So if these guys have a plus sign, and we remember from our equilibrium work, what should the sign be here for the change? Anybody? Connor?
Negative.
Be negative 10 to the minus 2.34. All right, good. And that, okay, let's go ahead and figure that out, and you can certainly do that on your calculator and check me. But I think you're going to find that that's roughly 0.0045, 0.46, somewhere along in there. That's a minus. Again, this is 0.046 plus, got to get my dot there, and again, this is dot, need a 0 there, make it clear. 0.046. Okay, and if that is the case, then all we have to do now, we just literally add columns, you remember? So if someone would add 0.0516 plus a negative or minus 0.0046, you're going to come up with something on the order of 0.047. So we're taking this guy here, right? And we're subtracting that, okay? And we're coming up with 0.047. Same thing over here, 0, right? Plus that number there is equal to 0.0046. And we're finishing up here. I think we'll be able to get to the end of this table, and then we're going to have to stop. Okay, at 0.0046. Now, so we have our equilibrium concentrations, and let's go back. What did they ask us for? Ka. All right, and I'm just going to go right to the top here. Ka is equal to the hydronium ion concentration, 0.046 dot, so point times the nitrous anion, and that's the same thing. So I'm just going to square that out of lack of space. I don't have to do that. I wish I could write it out, but I can't. And then it's divided by 0.0. I can't write it. The point doesn't work well. 0.0. Oh, I'm sorry. It's 0.047. And that equals, somebody may have already calculated it, but it's 4.6 times 10 to the minus 4.